Hello everyone, I am Rakibul Hasan, Assistant Professor of Assam Downtown University. Today I am going to discuss about RGB contact lens material. Number one material is cellulose acetate butyrate (CAB). CAB is an early contact lens material derived from a natural polysaccharide cellulose. Number two, it usually contains about 13% acetyl groups, 37% butyryl groups, and 1 to 2% free hydroxyl groups. Number 3, it is a thermoplastic which had relatively higher oxygen permeability compared to PMMA, polymethyl methacrylate. It can be absorbed 2% of moisture, which in turn may lead to wrapping and distortion. And last one is, it has a low decay in the range of 4 to 8 and was difficult to manufacture by lathing technique. Here, cellulose acetate butyrate, the first RGB contact lens, were made from CAB. CAB has slightly better oxygen permeability than PAMA. It is strong and durability. Oxygen permeability means contact lens is the barrier which reduces the amount of oxygen reaching the cornea. The value of oxygen permeability is the indicator for measuring this barrier. Higher value indicates that more oxygen can reach the cornea. Oxygen permeability means decay. Decay is the value for diffusivity, that is D, of the oxygen goes through the lens times solubility, that is K. Next, number 2, siloxane methacrylate. Here, the oxygen permeability or rigid lenses was improved by copolymerization of methyl methacrylate with certain siloxane, alkyl and methacrylate monomers. This is the most successful RGB material even today also, which was introduced in 1970 years. The decay values of 12 to 60% are accessible in this group. Their surface also scratches easily and may cause flexure if made thinner than the critical thickness. Here, in the advent of silicone uses in the medical industry, siloxane methacrylate material was developed in 1970 by using silicon molecules bonded to methyl methacrylate structures, making a contact lens more oxygen permeable. Siloxane acrylates material was patented in 1974 under the name Polycon and was introduced commercially in 1979, which leave the wearing time longer than CAB, cellulose acetate butyrate, due to its high oxygen permeability without showing any hypoxic changes in the cornea. However, it was observed that the siloxane acrylate lenses tend to attract more of lipid and less of protein deposits on the lens surface, making the care of newer RGB contact lens materials different than the previous lens. These deposits lead to larger lens life than the previous lenses. Next, number 3, fluorosiloxane methacrylates. Here, these materials were derived from siloxane alkyl methacrylate, but in addition contain some fluorinated monomers. The addition of fluorine improved the oxygen permeability of siloxane methacrylates further. The decay shift range from 40 to 100% or more, which makes it possible for extended wear also. Here, in order to improve wettability and oxygen transmissibility, the use of fluorosiloxane methacrylates, and the another name is fluorosilicon acrylates, become popular. In general, the silicon or fluorine part of the polymers gives the material its high oxygen transmissibility, while the methacrylate enhances optical quality and stability. Here, what is transmissibility? Decay by T. Here, compared to oxygen permeability, oxygen transmissibility takes the value T. T means the thickness of contact lens into consideration, that is, oxygen transmissibility is equally related to the thickness, material and geometric design of the lens. The value of its thickness is the mean of the measurement of its thinnest central optic zone. But since the lens with different power has different thickness. Next, number 4, alkyl styrene copolymers butyl styrene. Here, these materials are low density materials which have better oxygen permeability due to their looseness in the range of 25% is still not competitive. Alkyl styrene is made from copolymers with hydrophilic monomers such as phenyl, prolindin or hydroxymethyl methacrylate. Yet, this material is not so much in commercial use. Here, the first widely available contact lenses were made of polymethyl methacrylate, which is an excellent optical biomaterial in almost all respects except for its partial impermeability to oxygen. Several materials that were especially developed for the manufacture of RGB gas permeable contact lenses are copolymers of methyl methacrylate with siloxane alkyl methacrylate to compensate for the hydrophobic character imparted to the polymer by the high siloxane content of this copolymer. The copolymer also contains some hydrophilic comonomers. The most commonly used hydrophilic comonomer in RGB contact lens is methacrylic acid. There are also minor cross-linking agents. A diversity of RGB contact lenses consisting of different but closely related comonomers used in a variety of proportion to obtain the most desirable properties are commercially available. However, any change in the chemistry of the contact lens material might strongly affect its clinical performance. As a general rule, the oxygen permeability coefficient of the siloxane alkyl methacrylate contact lens materials is inversely proportional to the density. The development of the fluorine containing contact lenses and the realization that the fluoro derivatives may improve oxygen permeability and resistance to deposit formation caused contact lens chemists to include a fluoroalkyl methacrylate or a similar fluorine content monomer as an additional ingredient in the selection alkyl methacrylate RGP contact lens materials. Hope you all understood the RGP contact lens material. Thank you.